what we learned about in physics fell under the energy category. As we look at all the different types of energy, you're probably going, wow, that's pretty much a syllabus for what we covered in physics. And in this class, what we'll be doing is transitioning to studying about matter, the material of the universe. So what I'd like you to do is I'd like you to take a look at the back side of your R2. R2 is the one I just handed out. And we're going to start on the back side. What do you want to ask me? Don't worry about the notes on the right-hand side for matter. We're going to get back to those shortly. And so on the back side of R2, everything in the universe is either. You may add in the arrows, or you can leave it. It's up to you. So the first type of energy, the first type next to the little dash over on the left-hand side, is mechanical. Now, most likely you don't recognize that term mechanical, because in physics, there's only about a paragraph that talks about the word mechanical energy. And then it breaks mechanical energy up into two different types of mechanical energy. And as soon as I put these up, you'll go, oh yeah. First one, kinetic. Second one, potential. But those two energies really fell under the bigger caption of mechanical. It's probably just didn't spend that much time on it in physics, the term mechanical. Kinetic energy, we're talking about energy of motion. Anytime something's moving, it has mechanical energy. Potential energy, on the other hand, is energy due to the position of something. You squeeze a spring together, it's got energy that it can give off when you let go of that spring. If you pick an object up above the ground, it now has the potential to do something. It has the potential to fall. So kinetic energy, energy of motion. Potential energy, energy due to the position of an object. Two types of mechanical energy. And then the next thing that you probably study, probably not in this order because physics teachers typically do it in different orders. Sound. Sound is another type of energy. Right now my vocal cords are vibrating. They are hitting atoms and molecules that are in my mouth, and they are bumping into other atoms or molecules, which in turn bump into other atoms or molecules, which in turn bump into other atoms or molecules, until finally that vibration that's moving, not the actual substance, but the vibration that's moving, hits your eardrum and you can hear what I'm saying. Sound is another form of energy. Third guy, electrical. Electrical energy. When you can get all the electrons to move in the same direction at the same time, you can create what is called electricity, electrical energy, magnetic energy. We learned that a charge has an electric field around it. We learned that if you can get that charge to move in physics, not only does it have an electric charge, it also has a magnetic field around it. And as you played with magnets, you felt that field before. Magnetic energy. And we put those two guys together to form electromagnetic energy. Electromagnetic energy. There are several subcategories of electromagnetic energy. Several subcategories of electromagnetic energy. The one you probably spent the most time on in physics was the subcategory of light. In fact, sometimes we study light so much in physics that we forget we're actually under the subcategory of electromagnetic energy. There are several other forms or types of electromagnetic energy, such as radio waves, UV waves, X-rays, those types of things. There's a few others that we'll talk about in this class, like gamma rays. Thermal energy. In physics, you probably did not talk about thermal energy. Thermal energy, as well as the next one, chemical, and as well as the one after that, nuclear, is what energies we will be focusing on in this class. We will primarily in this class be spending our time on the right side dealing with matter. But there most of the energy we covered in physics, but there was a few energy terms that we'll be focusing on in this class: thermal, chemical, and nuclear. So those should not look too familiar to you. And then, finally, in physics, we also covered the transfer of energy. Some people consider the transfer of energy not to be actual energy because it's the transfer of energy, but we're going to consider it to be a type of energy. Two ways energy can be transferred: through work as well as heat. As you look at that, I think that you would agree with me that that's almost the physics syllabus. As you went, there were a couple other things. Like at the beginning of the semester, I think you covered Newton's 3 laws of motion. Okay. Inertia, force equals m times a, and action-reaction forces. Then you probably went into the gravitational pulls, where you're dealing with the Earth and the pull on the moon and those type of things. But other than those two concepts, I think most of what you studied had to do with kinetic and potential energy, sound, light, heat, work, Coulomb's law, dealing with the electrical energy. And now in this class, during the semester, we'll cover the thermal, the chemical, as well as the nuclear. But most of what we're going to be doing in this class is the other side. Everything in the universe can be either matter or energy. In physics, we focused on energy. In this class, we're going to be focusing on matter. First thing about matter. All matter exists as either an element or a compound. So please add that in over on the right-hand side notes next to that first dash. And you might have already. All matter exists as either an element or a compound. Now, please take a look back at our learning objective. Our learning objective states that all matter is composed. Composed is just a fancy word for made up of. All matter is composed of tiny particles called atoms. So, if we were to take the material of the universe, that's what our definition of matter was. If we were to take the material of the universe and we got onto our magic school bus, or instead of magic school bus, we stuck this under a microscope, very fancy atomic microscope, and start zooming in, zooming in, zooming in. Eventually, what we would see this material made up of are tiny individual particles stacked next to each other. This is matter. It's the material of the universe, like the desk, like the table, like the chairs, like the ground, like the grass, like the air that we're breathing. The material of the universe, matter. And because this is matter, it's made up of tiny particles that we're going to call atoms. If we were to zoom in and enlarge this, eventually we would see individual atoms stacked next to each other that makes up this substance. Now, matter can exist two ways. It can exist as either an element or it can exist as a compound. Now, I know we didn't write down number 3 and number 4, which we'll write down tomorrow, but a substance that has only one type of atom, if there's only one type, we call it an element. But a substance that has 2 or more types of atoms is considered a compound. For instance, if I were to take and break this apart, if you need water, you can get it. It's up to you. You can stay. Doesn't matter. So, if I were to take this substance, and if I could, which I can't, but if I pretended to break this up into its individual particles, what we would be left with is a pile of atoms. And if I were to take each one of those atoms that make up this material, or this matter, if I were to take each one of those atoms, what we would find is each one of those atoms looks exactly the same. They are all exactly the same type of atom. Because this is a substance that contains only one type of atom, we're going to call it an element. An element is a substance that contains only one type of atom.